In this lesson, we'll work right triangle application problems that involve the bearing concept and additional concepts. I'd like to begin the lesson by defining bearing. When a single angle is given, such as 156 degrees, it is understood that the bearing is measured in a clockwise direction from due north. So if we said that a plane was flying on a bearing of 156 degrees, and we'll just pretend like that the airport is right here, that would mean that it was flying out in this direction. Notice this angle right here is 156 degrees, and that's what we mean by a bearing of 156 degrees. That the angle between north and the direction that the plane is flying is 156 degrees. Let's look at another example. Suppose we were talking about a ship, and we said that the ship was sailing on a bearing of 190 degrees. Well, let's draw our north, and then we would know that this angle right here between north and the line that the ship was sailing on was 190 degrees, and we'll just approximate that. We know, of course, that around to here would be 180 degrees, so we would want to go just 10 degrees further. And my sketch is maybe not real accurate, but hopefully close enough so that you can get the idea. Let's look at a second definition of bearing, and this is when we give two directions. The second common system for expressing bearing starts with the north-south line and uses an acute angle to show the direction, either east or west, from the line. Now, we're sort of assuming here that we all know that this direction is north, east, south, west. So here's my north line, and the north 58 degrees east would mean that this angle was 58 degrees, and notice this is the east direction, so my plane would be flying out on this line somewhere. Let's look at some more examples. Suppose we said that the ship was sailing south 20 degrees west. Well, first let's draw south, and then of course west would be in this direction, so we would know that this angle between south and the line that our ship was sailing on was 20 degrees. So that's what we would mean by that. Now, I would like for us to work a problem and define the bearings for a better understanding, because our application problems will be telling us that the ship or the car or a plane is on a certain bearing, and we have to know how to sketch that and what that means. So let's look at this problem. It says, find the bearing of a ship located at the point -44. Express the bearing using both methods. Well, first let's just draw a rectangular coordinate system. Of course, that means -44 on the rectangular coordinate system, doesn't it? So I'll let this unit represent 1, so of course that's negative 1, and then so I won't label all of those. We'll just count. Let's find that point, negative 4, 4. 1, 2, 3, 4, up, 1, 2, 3. So my ship is at this point right here, and I'm going to go ahead and draw this line. Now the truth is the ship could be anywhere on this line, and it might be worth noting, just looking at this, what does this line do that's got this point negative 4, 4? What are the other points? Well, it would have negative 3, 3, negative 2, 2, negative 1, 1 on it, and what we know from algebra it does is it splits the second quadrant so that this angle is 45 degrees and this angle also is 45 degrees. So let's give first the single angle type bearing, which of course for the single angle type bearing we are moving in a clockwise direction from north. We need to know what this angle is, don't we? From there to there, well, of course we know that's 90 plus 90 more, which would be 180, plus 90 more, which would be 270, plus 45, which that's 315 degrees. Now, if we said that the bearing of the ship was 315 degrees, then it would mean that it was headed out in this direction and it was somewhere on this line. Specifically, they told us it was at negative 4, 4. Now, to give the bearing using the two directions, of course we either go north or south, but we have to use an acute angle. So we would say north, and then which way? West, and how many degrees? So it would be north, 45 degrees west. Remember that for the bearing that gives the two directions, that the first direction is always either north or south, and the second direction is either east or west, and the angle in between should be an acute angle. Let's look at a bearing application problem. It says a ship travels 61 kilometers on a bearing of 23 degrees and then travels on a bearing of 113 degrees for 130 kilometers. Find the distance traveled from the starting point to the ending point. See figure. Well, sometimes on a problem like this, a figure is drawn for us, and sometimes we have to sketch it ourselves. What I'd like to start out with is to be sure that you realize that this is my little ship, and that what we mean by this problem is that the ship started right here and it went in this direction, then it changed bearings and went in this direction, and here's where the ship is. Now, the distance they want us to find is the distance from this starting point to where the ship is right now, which is just labeled D for us. And what we know in this problem is that it first traveled on a bearing of 23 degrees, and the distance it traveled was 61 kilometers. So I'm going to label this as 61 kilometers. And then when it changed bearings, it traveled 130 kilometers. And so if this is a right triangle, then it would appear that we've got a leg here and a leg here. We're just looking for the hypotenuse, but we can't just assume that this is a right triangle. What we have to use is our knowledge of geometry to show that it is, and then if it is, we'll be able to use Pythagoras to find that hypotenuse. So let's see what our bearings tell us. When I work these problems, I like to draw the north-south line to get my bearing, if you will. And so at my starting point, I would sketch in this north-south line, And since the ship was traveling on a bearing of 23 degrees, since it's a single bearing, I know that that means the angle between due north and the line that the ship is traveling on is 23 degrees. So I know that angle's 23 degrees. And so let's go on up to this next point where I'm given another bearing. And once again, I like to sketch that north-south line. And what I know is at this point, the ship turned and started on a bearing of 113 degrees. So that means that this angle from due north to the line that the ship is traveling on is 113 degrees. Well, look what happens. This north-south line is parallel to this north-south line, and this line crosses those two parallel lines and is what we call a transversal. And a transversal with these two parallel lines forms certain special angle relationships. And what do we call this angle and this little angle right there? They're alternate interior angles, aren't they? And what's the relationship? Well, we know alternate interior angles are equal. So we know that this angle is 23 degrees. Now, can we figure out what the measure of this angle is? Well, we know all the way down to right here is 180 degrees. We know that that is 113 degrees. So if we'll say 180 subtract 113, we'll figure out what the measure of that angle is. Let's see. 3 from 10 is 7. 1 from 7 is 6. So that angle measures 67 degrees. Now, what's the measure of this angle? Well, it's 23 degrees plus 67 degrees, which guess what that adds up to? It equals 90, doesn't it? So we know we have a right triangle. D is the side across from the right angle. So it is the hypotenuse. How do we find the hypotenuse when we're given two legs? Well, we take the square root of 61 squared plus 130 squared. Now, I use a scientific calculator, and on my scientific calculator, you enter the 61, hit the square button, plus 130, hit the square button, hit your equals, so it will do your adding for you, and then take the square root. And when I calculate that, I get 143.6000, and let's see what I need to round to. These two legs that I was given, that's two significant digits, and the 1 and the 3 makes that two significant digits. So I only need to look at this 143. I'm going to round to two significant digits. I just need the hundreds and the tens, so I'll look at the ones. Since that's less than 5, I'll leave the 4 alone, and I replace that 3 with a 0. So rounded, this is 140, and of course it will be kilometers because the 61 and the 130 are kilometers. Let's work another bearing application problem. This says two lighthouses are located on a north-south line. From Lighthouse A, the bearing of a ship 2,370 meters away is 126 degrees 10 minutes. From Lighthouse B, the bearing of the ship is 36 degrees 10 minutes. Find the distance between the lighthouses. Well, let's see here. Let's sketch a drawing, and of course it's a sketch, says 2 lighthouses are located on a north-south line, and they've called those A and B. So let's sketch our north-south line. And I'm going to put lighthouse A there and lighthouse B there, and that's what they mean by located on a north-south line. And then apparently what I've got is a ship, and it's out here, and they're giving me the directions of the ship from A and from B. So let's see if I can sort of sketch where the ship is. It says from lighthouse A, the bearing of a ship, and it tells me how far away it is 126 degrees 10 minutes. Well, here's what I'm going to do. I don't want to use the black marker, but maybe, see, to get that bearing, what I really need is the north, but I sort of make my rectangular coordinate system when I'm sketching them because that helps me. I know from there to there is 90, and 126 then is just about 36 more degrees. I know that all the way down here is to 180, but that sort of helps me estimate just a little bit better. So I'm going to do what I think is this angle to the best of my ability and label it 126 degrees 10 minutes, and then I'm going to sketch sort of out in this direction and put my ship out here. And so here's my ship, and I'll just do that little ship thing. And the other information they give me is that it says from lighthouse A, the bearing of a ship 2,370 meters away. So that means that ship is 2,370 meters from lighthouse A, which means that this distance is 2,370. And then it says from lighthouse B, the bearing of the ship is, well, I guess it could have left from lighthouse B too, couldn't it? So let's see what we know here. Well, this would create the line from lighthouse B, and if its bearing from lighthouse B is 36 degrees 10 minutes, then of course this is the north line, and that means that the angle between the north line and this line of direction that the ship is actually on is 36 degrees 10 minutes. So I know that this angle right here is 36 degrees 10 minutes. Now, do I know this is a right triangle? Well, no, I don't know that, do I? But what can I figure out? I know this angle right here, don't I? I can figure this angle out right here the same way I did in that last problem. I know all the way down here is 180, and so to figure out what this angle is, if this angle is 126 degrees 10 minutes, I will subtract 126 degrees 10 minutes from 180. Now, of course, I need to rewrite that 180 as 179 degrees 60 minutes. 60 minutes is 1 degree, and 1 degree plus 179 degrees gives me 180, and then I can subtract the 126 degrees 10 minutes. 10 from 60 would leave me with 50 minutes. 6 from 9 would be 3, and this starts my degrees, doesn't it? 2 from 7 leaves me 5. So I know this angle right here is 53 degrees 50 minutes. Well, to figure out if this is a right triangle, I'm going to add these two angles. These would be the two acute angles. And 50 minutes plus 10 minutes is 60 minutes. 3 plus 6 would give me 9, and 5 plus 3 would give me 8. And sure enough, 89 degrees, 60 minutes is 90 degrees. So if the sum of these angles is 90, I know, of course, that a triangle has 180 degrees when I add the 3 angles. So that means that this third angle must be 90 degrees. So I have a right triangle here. Now the question is, let's see. The question is, maybe it'd be better to do it like this. I know this side and I know these 2 angles, and what I want to do is to find this side, don't I? And I'll just call this side D. They're calling it the distance between lighthouse A and lighthouse B, and D is the hypotenuse because it's across from the right angle. So it's like I've got 2 angles, a leg, and I'm looking for the hypotenuse. It probably would not matter which one of these angles that I used. I think that maybe I'm going to choose to use this angle down here. So I've got this angle, I've got the leg that is opposite that angle, and then I have the hypotenuse that I'm looking for. The function that uses opposite and hypotenuse of this angle is the sine. So when I set this up, I'm going to say the sine of 36 degrees 10 minutes equals the side that is opposite it, the 2,370, divided by the hypotenuse, which is D. And of course, to solve here, I will multiply both sides by D. The D's divide to 1. So I've got D times the sine of 36 degrees 10 minutes equals 2,370. To undo multiplying D by the sine of 36 degrees 10 minutes, I'll divide both sides of the equation by the sine of 36 degrees 10 minutes. These divide to 1. So to calculate D, I have to take 2,370 and divide it by the sine of 36 degrees 10 minutes. Now just be careful when you calculate it, since this is 36 degrees 10 minutes, you have to put this in your calculator and convert it to decimal degrees. So be sure that you do that, and we've calculated several of these in our applications, so I'll assume that you know how to do that. If not, you might want to get the tape on right triangle applications that's just entitled Applications of Right Triangles. And here's the number that I got, 4,016, and let's talk about what I have to round to. Because this number 2,370 is rounded to 3 significant digits, and that represents one of the sides of my triangle, and my D represents one of the sides of my triangle, then I want to round it also to 3 significant digits, which means I'll need the thousands, the hundreds, the tens place. So I'll look at the ones place, and since that's a 6, it tells me to add 1. So I'll have 4,000. I'll write the 0 in the hundreds, a 2 in the tens, and of course 0 in the ones place. So rounded to 3 significant digits, this answer is 4,020, and this would be meters because the 2,370 is meters. Now I'd like for us to work a bearing application problem that uses the two-directional system for bearings. Says the bearing from Atlanta to Macon is south 27 degrees east, and the bearing from Macon to Augusta is north 60 degrees east. An automobile traveling at 75 miles per hour needs 1 hour to go from Atlanta to Macon and 1 4/10 hours to go from Macon to Augusta. Find the distance from Atlanta to Augusta. Well, let's draw this sketch. Let's see, we start off with the bearing from Atlanta to Macon, and it gives us the direction, and then from Macon to Augusta. Of course, this is a sketch, and I try to make it just a little bit accurate. If it takes the automobile an hour to go from Atlanta to Macon and an hour and 4/10 to go from Macon to Augusta, it's pretty obvious that the distance from Macon to Augusta is a little bit longer than the distance from Atlanta to Macon. So I do want to draw it that way. I'm going to start off right here, and that's going to represent Atlanta. And so I'm going to first try to get a direction to Macon. So if it's from Atlanta to Macon, that means, and I like to sketch this north-south line to help me, says that Macon is south, so that would be this direction, 27 degrees east. So I know that Macon is out here, and I'll just sketch it a certain distance. But what's important about this is I know that this angle right here is 27 degrees. So I want to label that angle. And then this point right here I'm using for my Macon. And it didn't give me the distance, but I know the distance. If the car's traveling 75 miles an hour and it just takes an hour to go from Atlanta to Macon, then that distance is 75 miles, isn't it? So that was pretty easy. Let's see if we can get a location for Augusta. Let's see what it tells us. It says the bearing from Macon, so I start at Macon, to Augusta is north 63 degrees east. And once again, I like to sort of do my north-south and my east-west. It just helps me be a little more accurate with my bearing. So north, and then 63 degrees east would be this direction. Of course, I know all the way down is 90. So I'm just going to estimate that I know that angle is 63 degrees. And I know that this distance, in this case, has to be longer. I think I've made it just a little bit too long, a little bit longer, because this took an hour and this took like an hour and 4/10. I think, see, you can't be for sure, and that's one of the problems, because you can draw your drawing and it may not look like a right triangle at all, and that's why you have to use your geometry to determine for sure it's a right triangle and where the right angle is. So I'm going to mark this as my Augusta, and it says find the distance from Atlanta to Augusta, and that would be that distance. And it just happens that that's straight across there. It doesn't have to be. I didn't try to draw it that way. It just worked out in my sketch. let's see here. We've got to prove that this is a right triangle. But the other thing we can do is we can figure out what the length of this side is, because we know that we're traveling 75 miles per hour, and we know how long it took us to travel. And do you remember your distance formula? How do you find the distance when you know the rate that you're traveling and the time? That's the old distance equals rate times time, isn't it? So to get this distance, which this of course is a different distance, maybe we'll call this the MA distance, meaning the distance from Macon to Atlanta. We'll take the rate, which is 75 miles per hour, and we'll multiply it by the time, which is 1 4/10, and we get that distance is 105 what? It would be 105 miles, wouldn't it? And the 75 would be miles also. I'm not going to write the miles, but just keep that in mind. So I know that the length of this side of this triangle is 105. Now let's determine if it is a right triangle. How can I do that? Well, once again, focus on this north-south, this north-south. This line forms a transversal, and once again, this angle and this angle are alternate interior angles, which means they're equal. So that angle is 27 degrees. So what's the measure of this angle? Well, take your 27 and your 63 and add it, and sure enough, it's 90 degrees. So we have a right angle. We're given the two legs of that right angle, and we're supposed to find the hypotenuse, which is the side across from the right angle. These are the legs of the right triangle, aren't they? And we're looking for the hypotenuse, which is across from the right angle. And how do we find the hypotenuse when we know what the legs are? We'll use Pythagoras, won't we? D equals the square root of 75 squared plus 105 squared. We've already worked one problem like this today, and we will need to round this. And let's see what we need to round to. Well, look at what we're given. Our angles are 2 significant digits. Our speed is 2 significant digits. Our time are 2 significant digits. So we want to round to 2 significant digits. So I've got 129.034879, but 2 significant digits means hundreds and tens in this case. So look at your 9, and because it's a 9, we're going to add 1 to our 2. So rounded, we find that the distance from Atlanta to Augusta is approximately 130, and in this case it would be miles, wouldn't it? Now I'd like for us to look at a very challenging problem that really has nothing to do with bearings. The challenge is more in the algebra and combining the trig with it. So let's look at this next problem. It says find h as indicated in the figure, and look at what we have here. We have a right triangle. We're trying to find this distance h, which is a leg for this right triangle. We are given that this angle right here is 40 5/10 degrees. We're given that this angle is 23 6/10 degrees. And then we're given that the distance from this point to this point is 432 feet. Well, the problem here is we're used to working problems. We're used to having, say, this angle and knowing the length of this whole side and then finding h. That's no big deal. But we don't have that in this case. So here's what we have to do. First of all, we're going to label this distance x, and we're going to figure out what x is. And once we know what x is, we'll have a leg for this right triangle, we'll have this angle, and we can figure out what h is. But let's look at how we're going to figure out what x is. We know two relationships. We know that for this small triangle, that h is the opposite leg for this angle and x is the adjacent leg for this angle. So we could say the tangent of 40.5 degrees equals h divided by x. The next thing that I'm going to do is I'm going to solve this equation for h. And I can do that by multiplying both sides by x. Those will divide out. And from this equation, I know that h is equal to x times the tangent of 40.5 degrees. Now, I have an equation in two unknowns. What I need is another equation in two unknowns, and let me show you how I'm going to get that. Let's look at this large right triangle. I have this angle, I have this side h, which is opposite this angle, and I have this side, which is adjacent to this angle. Now, what would the expression for this length from here to here be? How could I write that? That length would be x plus 432, wouldn't it? So let's set up another trig function relationship. The tangent of 23.6 degrees will equal the length of the opposite leg, which is h, divided by the length of this adjacent leg, which is x plus 432. Now what I'm going to do for this equation is solve it for h also. So I'll have two equations solved for h, and what I need to do is I need to clear this denominator. So I can do that by multiplying both sides of the equation by the denominator, x plus 432. Those divide out, and for this equation, I have h equals x plus 432 times the tangent of 23.6 degrees. Now I have two equations with my two variables h and x, and it's called a system of equations. Do you remember from algebra how to solve a system of equations? Well, one way is to use substitution. Since h is equal to this, I can take this x times the tangent of 40.5 degrees and substitute it in for the h on the left side of this equation. And when I do that, I get this monstrous equation. Look at this. In place of h, I'll have x times the tangent of 40.5 degrees equals, and on the other side, I'll have x plus 432 times the tangent of 23.6 degrees. Now I have one equation in terms of one variable x. In order to solve this, what I need to do is to simplify this right side of the equation. Now remember, this is just a number, isn't it? So I have two terms times a number. Remember what I do? And maybe this would help you. If I had x plus y with a 2 out there, how do I remove the parentheses? I can distribute the 2 to each of those. I can say x times 2 is 2x, and y times 2 is 2y. So I'm going to do that here. I'm going to distribute the x to this number and then distribute the 432 to that number. And so when I do that, on the left I'll have x times the tangent of 40.5 degrees equals x times the tangent of 23.6 degrees. X times the tangent of 23.6 degrees is just x times the tangent of 23.6 degrees plus, and then when I distribute the 432 to the tangent 23.6 degrees, I'll have 432 times the tangent of 23.6 degrees. Now I need to solve that equation for x. Well, my first question to you is, how many terms do I have on this side of the equation? That's just one term, isn't it? And how many terms do I have on this side? That's 2 terms. Well, the next thing that's important for you to notice is which of those terms are x terms. Well, this term has an x and that term has an x. So to solve the equation for x, I want to get both the x terms on the same side of the equation. So I need to move this term over with this term. So how do I move a term from one side of the equation to the other? Well, I want to subtract it from both sides. So when I do, I'll keep this term where it is. When I subtract this from both sides, I'll subtract it from the left. Of course, when I subtract it from over here, x times the tangent of 23.6 degrees minus x times the tangent of 23.6 degrees results in 0, and the only term that I will have then on the right side of that equation is 432 times the tangent of 23.6 degrees. Now the next thing that I do, this means x times the tangent of 40.5 degrees, and this means x times the tangent of 23.6 degrees. X is a factor of both of these terms, so I will factor the x out. In this first term, I'm left with the tangent of 40.5 degrees, subtract, and when I factor the x out of the second term, I'm left with the tangent of 23.6 degrees. And I didn't do anything on the other side of the equation. And be sure you check. Anytime you take a common factor out of terms, you should be able to multiply back and get this. And sure, if I say x times the tangent of 40.5 degrees, I end up with this. And x times the tangent of 23.6 degrees, I end up with that. All right. Now, x has been multiplied by this. To undo the multiplication, I will divide. So next I will divide both sides of the equation by this quantity. And I think I'm going to have to write fairly small, or I won't get it all on this page. But maybe I can write large enough so hopefully you can read it. So I'm dividing by that, and it's a factor, and I have to do that over here. Divide by the same thing. Okay? And what happens is these divide to 1, and so we have that x is equal to 432 times the tangent of 23.6 degrees divided by the tangent of 40.5 degrees minus the tangent of 23.6 degrees. So to figure out what x is, we need to calculate this, and we haven't calculated one like this. I would suggest to you, when you put this in your calculator, it doesn't matter which kind, you're going to need these parentheses, so that might help you to remember that. I will give you the keystrokes for a scientific calculator. Let's see, we'll go 432 times, and then to find the tangent of 23.6 degrees, I'll have to put the 23.6 in times the tangent, and then I'll have to do the divided by, and then I'll need parentheses, and then I'll have to input this. On a scientific, of course, I'll put that angle in first, then I'll hit my tangent button, subtract, and then I'll have to put that angle in first, and hit that tangent button. Close those parentheses, and then hit your equal to actually make it divide. And if you're using a graphing calculator, it works pretty much the same. You could just put this and then your times. The difference is, of course, that you'll hit your tangent button, then your 23.6, and then the divide. Use your parentheses, put your tangent, then your 40.5, subtract, hit your tangent, then your 23.6, close parentheses, and of course, instead of your equals, you will use your enter button. So let's see, let's calculate this. Alright, here's what I got, and we will certainly need to round this, but let's just look at what I got. I got 452.39, and it keeps on going, 70212, but we don't need all those digits to round. Let's go back up here and look at this original and see what we were given. Those angles are to the nearest tenth, which is 3 significant digits, and that's to 3 significant digits. So I'm going to round my x to 3 significant digits. So my x here to 3 significant digits, let's see, we'll look at the 2. Since it's a 2, we'll leave the 5 alone and write a 0 in place of the 2. So that would be 450 feet, wouldn't it? Well, it would be if I was supposed to round to 2 significant digits. I don't know where my head is. Pardon me. Let's go back and let's redo this for 3 significant digits. For 3 significant digits, I need to look at my tens place. I have a 3, so it tells me to leave this alone. And of course, those I just drop off. So to 3 significant digits, my x is 452 feet. Now that we know x, we can go back and find h fairly easily. I want to go ahead and label my x here. Let's see. So my x distance right here is 452. Now to find h, notice right here in my work, I solved for h here and I solved for h here, but I think this one would be the easier one to work with. Don't I know that h is equal to x times the tangent of 40.5 degrees? So what I'm going to do here is to say h equals, and substitute my 452 in for my x and multiply it by the tangent of 40.5 degrees. And of course I want to round that to 3 significant digits. When I calculate that, I get 386.04444698. Rounding to 3 significant digits, since that's a 0, I just drop it off, and I'll have that h is 386 feet. So this distance from here to here measures 386 feet. Now I'd like for us to look at an application problem that works just like that problem number 5 we just worked. It says the angle of elevation from a point on the ground to the top of a tree is 36 degrees 40 minutes. The angle of elevation from a point 112 feet further back to the top of the tree is 28 degrees 20 minutes. Find the height of the tree. Well, let's draw a sketch, and I'll let this represent my tree, and I'm looking for the height, so that will be h. And I'm told that the angle of elevation from a point on the ground, well, this will be my point on the ground, and we will assume that the tree is perpendicular to the ground, forming that 90-degree angle. And we know that the angle of elevation from this point on the ground to the top of the tree is 36 degrees 40 minutes. So this is the angle of elevation. So we'll label that 36 degrees 40 minutes. And then we're given the angle of elevation from a point 112 feet further back. So we'll move back, and this distance right here is 112 feet, and then we're given the angle of elevation, which is, and I'll write it up here, 28 degrees 20 minutes. So this angle right here is 28 degrees 20 minutes. This distance from here to here is 112 feet, and this angle is 36 degrees 40 minutes. So what we will do is we'll use the fact that we have 2 right triangles, and h represents a leg for both of them, and we will set up 2 equations, and we'll let this distance from this point to the tree be the x distance. So when we look at this larger triangle, for this angle, h is opposite, and then this distance, which would be 112 plus x, would be the leg that's adjacent to our angle, which represents tangent function. So we can say that the tangent of 28 degrees, 20 minutes, equals the length of the opposite leg, which is h, divided by the length of the adjacent leg, which in this case is 112 plus x. We'll solve for h by multiplying both sides of the equation by 112 plus x. Of course, these divide to 1, and we get that h is equal to 112 plus x times the tangent of 28 degrees, 20 minutes. Now let's look at this smaller triangle. H would be the leg that is opposite the 36 degrees, 40 minutes. X is the leg that is adjacent to the angle that measures 36 degrees, 40 minutes. So we can also say that the tangent of 36 degrees, 40 minutes equals the length of the opposite leg, which is h in this case, divided by the length of the adjacent leg, which is x. Now we'll solve this equation for h by multiplying both sides of the equation by x. Of course, those divide to 1, and we get another expression for h. H equals x times the tangent of 36 degrees, 40 minutes. Now, for our next step, since we have two equations in two variables, we'll use the substitution method. And for this equation right here, we'll take what this h is equal to, and we will substitute it in for that h. So we will have, in place of this h, 112 plus x times the tangent of 28 degrees, 20 minutes, equals x times the tangent of 36 degrees, 40 minutes. The next thing that we will do to solve this equation is to remove the parentheses. So remember, we'll say 112 times the tangent of 28 degrees, 20 minutes, plus, and then we'll say x times the tangent of 28 degrees, 20 minutes, equals, and on the other side, we'll have x times the tangent of 36 degrees, 40 minutes. Now we want both of the x terms on the same side of the equation. These are our two x terms. This is our term that doesn't have an x. So we want this to stay on the left by itself. So we'll say 112 times the tangent of 28 degrees, 20 minutes. And then to move this x term over with this other x term, we will subtract it from both sides of the equation. So what I'm going to do is write this x term first, x times the tangent of 36 degrees, 40 minutes, and then when I subtract that term from both sides of the equation, on the right side I'll have minus x times the tangent of 28 degrees, 20 minutes. Now the next thing that I'm going to do is to factor the x out of both of these terms. And when I do that, in the parentheses for the first term, I'm left with the tangent of 36 degrees, 40 minutes. And remember, when I factor out, I should be able to multiply this times this and get that back. Subtract, and in the second term, when I factor the x out, I'm left with the tangent of 28 degrees, 20 minutes. Now the next thing I want to do is to get the x by itself. Since x has been multiplied by this, to undo that multiplication, I need to divide both sides of the equation by this. Let's see if I can get it written on here neatly. So that'll be the division on this side. I ran over a little bit, didn't I? And over here, I'll divide by the same thing. And of course, on this left side, those divide to 1. So what I have is that x is equal to, and it will be 112 times the tangent of 28 degrees, 20 minutes, divided by the tangent of 36 degrees, 40 minutes, minus the tangent of 28 degrees, 20 minutes. Well, this, of course, is the very same type of quantity that we had in problem 5, so I won't write the keystrokes for you. If you've forgotten, then rewind to the end of problem 5 to see what the keystrokes are. The only difference is that, and I would caution you here, remember that because this is 28 degrees 20 minutes, that you will have to convert that to decimal degrees. And of course this will have to be converted to decimal degrees, and of course that will have to be converted to decimal degrees. So that would be the only difference when you put this in your calculator. If you don't know the shortcut way to do that, then of course what you would do is put that 28 plus 20 divided by 60, close parentheses, and that is one way that you could do that, and then find the tangent of that. And depending on what type of calculator you're using, whether you push your tangent button first or your tangent button after you put your angle in. But don't forget to do that. And of course this would be 36 plus 40 divided by 60, and put that in parentheses if you're converting it like this. And what you should get is 294.186 something. Let's see here what we need to round to. Well, let's look back at this original problem. Notice that we were given this number to 3 significant digits, and our angle is to 3 significant digits, so that's what we want to round to. So I need to look at my tens place. Since it's a 1, my rounding here would just be 294 feet. And since it's a 1, I don't do anything to the 4, and of course I don't write the 1. So that's what my x is. One thing I would remind you is remember that for this denominator you are going to want to put that in parentheses, and if you're converting using this manner, for you want to put that angle in parentheses and this angle in parentheses also. Now let's find that h. We know that x is 294. Let's go back. We can use, let's see here, we can either use this relationship or this relationship, and I believe that this one would be the easier. So h equals, let's put 294 in for x, so it'll be 294 times the tangent of 36 degrees, 40 minutes. And I got that h was equal to, and I get 218.8, and I want to of course round to 3 significant digits. Since that's an 8, I will add 1 to the ones place, so h is 219 feet. That completes this lesson. If you're finished with the tape, please rewind it before you return it. Thank you.